Hi everyone, my name is Bryant Labajo Pahl. I'm the Science Communications Fellow for the School of Physical Sciences here at UC Irvine, and I'm very excited to be kicking off this year's Earth Month Takeover series. This year, we have a full suite of graduate students who have very exciting research that all contribute to this year's Earth Month theme, Invest in Our Planet. Throughout the series, you'll be learning about what these students are doing, why they're doing them, and what it is about the research that helps us invest in our planet. So be sure to drop a like and a follow to all the UCI ESS and the UCI School of Physical Sciences social media channels to stay up to date with all the Earth Month content and the Earth Month Takeover series. Without further ado, I'll be starting off the series. I'm a third-year Ph.D. candidate here in the Department of Earth System Science. Imagine yourself deep within the chamber of a remote cave. When you go to turn on your headlamps, you're surrounded by hundreds of active cave formations called speleothems. As the ceilings drip filtered water into the cave, a piece of Earth's history is etched into the surrounding stalagmites. Fast forward hundreds of thousands of years later, and you get me, a scientist who has the privilege of telling you these stories of Earth's past. My research is focused on reconstructing the past climate of the Earth, otherwise known as paleoclimate, using these cave stalagmites. By analyzing the geochemical markers of these cave formations layer by layer, we can precisely date these formations hundreds of thousands of years in the past and reconstruct changes in the surrounding hydrology and even the temperature of the cave in the past. So I was born and raised in Long Beach, California as a first-gen scholar from a low-income background. And at some point in middle school, I actually ended up moving to Joshua Tree, California, which if you're familiar with California, it's a very rural town. And so that shift from, living in an urban city to a rural one was pretty hard for me at first. But at some point I realized that I was surrounded by such really beautiful nature, really beautiful stars, and the national park was literally right there for me, and that is what sort of spearheaded me into the natural sciences. During my undergraduate studies at UC Santa Barbara, I ended up getting a part-time research position in a paleoclimate lab, and that sort of got me interested in research. But I think what really got me invested was I was working as a part-time journalist and, sort of interviewing people, learning about people's stories, and sort of understanding people's backgrounds. And I realized that what sort of connected the human aspect of paleoclimate was the storytelling. And for me, I think that storytelling is the really compelling part of paleoclimate. Like understanding how these stories can help inform our future is probably one of the biggest reasons why I am invested in this research. Well, first, let's say you were given an extraordinary book that could tell you the secrets to life's greatest mysteries. But unfortunately, you couldn't read that book. Paleoclimate is sort of the same way, especially with stalagmites. Stalagmites can sort of be thought of as one of these books, but more specifically, they can tell you stories about the past climate. The important thing is developing correct translations or interpretations for the records that we actually develop. These translations are made with modern-day assessments of the climate within the caves that we're interested in. All this to say that, fieldwork is what you would expect for someone who studies caves. We not only get to explore caves, but our primary goals for each excursion are to collect modern-day drip waters, temperature and CO2 measurements, serve as data loggers that we've placed previously, and all that information is used to help us interpret the climate records that we develop in labs. Gaining insight into Earth's past is critical for our understanding of the future of climate change. The Earth is billions of years old, but our instrumental record spans only a few hundred years. Thankfully, we have paleoclimate to extend those records past the instrumental record. By creating new records for critical points in Earth's history, like, say, warm periods, we can understand how Earth may respond to similar conditions in the future. Furthermore, we can expand our understanding of how climate change operates in different regions by extending the spatial scope of paleoclimate. So not only extending the temporal scale, but also the spatial scale. This will help us anticipate and better respond to future changes in Earth's climate.